In this video, we're going to talk about how to calculate percent abundance of an isotope as well as the average atomic mass of an element. So we learned the other day that atoms can form what we call isotopes. These are atoms of the same element. So for example, this is all the element magnesium. So these are all these circles represent atoms of magnesium. And we can see that the different magnesiums have different mass numbers. So we've got several here that are in black that have a mass number of 24. We have some that have a mass number of 25, and we have some that have a mass number of 26. But they're all the element magnesium because if we look, the bottom number is 12, meaning 12 protons. So the 12 protons don't change. If they did, we wouldn't have magnesium anymore. So these are all atoms of magnesium with different mass numbers. So when we calculate percent abundance, what we're doing is a percentage just like you would be in any other math class. We're going to count up the number that we have of each type. So the number that we have of each magnesium version. So if we take a look, magnesium 24, so this would be magnesium 24, if we count them up, so if I count all these black circles, this would show that we had 16 black circles. Okay. Then for magnesium 25, the ones that are in blue here, we have 2. And the ones that are magnesium 26, we also have 2. They're kind of in this tannish color. So when we look at this, magnesium, we've got 16 that have a mass number of 24, 2 that have a mass number of 25, and 2 that have a mass number of 26. Then the next thing we need to know is the total number. So if we add this all up together, 16 plus 2 is 18, plus 2 more is 20. We have 20 total atoms. So we're going to use this information to figure out the percent abundance, meaning what percent of the total number of atoms here have a specific mass number. So on this next one, we're going to use the information from the previous page, the 16, 2, 2, and 20, to do a calculation. So we're going to find the percent abundance of magnesium 24. And if we look back to the previous slide, magnesium 24, out of our 20 total atoms, 16 of them had a mass of 24. So magnesium 24, the percent abundance is going to be equal to 16 divided by 20. So 16 is the number of atoms that had a mass number of 24 divided by 20, which is the total number of atoms. And then we're going to multiply that by 100, which gives us 80%. So 80% of our magnesium atoms had a mass number of 24. We're going to do the same thing for our other isotope. So we have another isotope of magnesium with a mass number of 25. So percent abundance is going to be equal to the number of magnesium atoms that we had with a mass of 25, which was 2. And then we're going to divide that by 20, the total number of atoms that we had. So 2 divided by 20 times 100 is 10%. We're going to do this one more time for our third isotope of magnesium. So magnesium 26, percent abundance is equal to the number that we had with the mass of 26, so we had 2 of them, divided by 20, which is the total number of atoms that we had with the mass number of 26, times 100, which gives us 10%. So 80% had a mass of 24, 10% had a mass of 25, and 10% had a mass of 26. So why do we care about this? What we're going to do is we're going to use these percentages to figure out the average atomic mass of magnesium. So what we're going to do is average atomic mass is equal to the mass number times the percent. So 24 is the mass number for this particular isotope, and 80% of the magnesium atoms had a mass number of 24. So 24 times 80 plus 25, so that's the mass number of the second type of isotope, times its percent, which was 10, plus 26, which is the mass of the third isotope, times its percent, which was 10. So we're going to take all of these, we're going to add them together, and then we're going to divide everything. So once we're done with all of this, okay, we're going to divide by 100. This is the last step. So if you're going to enter this into your calculator, you're going to type in 24 times 80 plus 25 times 10 plus 26 times 10, hit enter first, then divide by 100. And this gives us a mass of 24.3. And if we look on the periodic table, this is the mass that you see for magnesium, 24.3. This is why it's not exactly 24, because we have some other isotopes with different masses, slightly heavier masses, 25 and 26. We're going to do another example, and this is going to be with chlorine. So here we didn't color code, but what you see, 35, so we have a number of chlorines with a mass number of 35. We have a number of chlorines with a mass number of 37. So we have 21, so if we go through and we count these, we had 21 atoms with a mass number of 35, and we had 7 atoms with a mass number of 37. So we're going to get the total number of chlorine by adding them together. 21 plus 7 is 28. So we're going to use this information to find percent abundance just like we did before, but because there's only 2 isotopes, we only have to do that calculation twice. So we're going to start with our chlorine 35. So the percent abundance, we're going to take 21 because we had 21 atoms with a mass of 35. We're going to divide it by 28, which was the total number of atoms that we had in our sample. So 21 divided by 28, and then we're going to multiply it by 100, which gives us a percent of 75%. We're going to do the same thing for our other one, and if we know about percentages, right, they have to add up to 100, so I would predict that this is going to be 25%, but we'll double check. So a percent abundance, we had 7 out of 28 that had a mass of 37. We're going to multiply that by 100, and sure enough, that comes out to 25%. We're going to use these percentages then to figure out the average atomic mass for chlorine. So to do that, the average atomic mass, we're going to take the mass of our first isotope, 35, times the percent that it existed, so 75%. We're going to add to that 37 times 25%. So we've got the mass number of 35 times the percent that it exists, plus 37, our next isotope, times the percent that it exists. You would type all this into your calculator first, hit enter, then divide by 100, which is going to give you 35.5 AMU. And if we look on the periodic table, we got really darn close because on the periodic table it says it's 35.45. So with rounding, this would be 35.5.